perception in all the conditions, and notifications should be close to the participant to be received, especially close to the board. And with that, I start talking about the second experiment, which goes on off-screen visualization. And to do that, I start with some general ambient light properties. So what can we actually visualize with that? First, we can show different locations. Second, different brightnesses. So the spots can have a different brightness. We can have different colors, as well as different sizes. However, when we place colors next to each other, this is what happens. We have a very whitish blur, and we need to account for that. So what we did is actually to add visual separators, like window blinds, so to make the colors more distinguishable. Another important thing is, especially when using brightness, to gamma correct the ambient light strips. Human perception is non-linear, so we need to account for that. And once we do that gamma correction, which we used a gamma of 3 here, we see that the ramp is much more visible. Now we needed some techniques to compare our techniques to. We chose halo and wedge, which are very well known in the community and serve as some sort of a baseline. Although they were actually designed for small interfaces, they are quite a standard when it comes to off-screen visualizations. Here I want to go to compare all the different techniques that we now have, also to remind you how halo and wedge work. So, about halo, we have concentric arcs on the center point of the off-screen object, which intersect with the actual visualization area. So we have a circle segment to visualize, which gives us visual hint of where the off-screen object is. Wedge uses triangles to draw or point the user's direction towards the off-screen object. Firefly actually utilizes the idea of different sizes for off-screen objects, and Glowworm different brightnesses. When we now add color to this image, we see that for Halo, Wedge, and Firefly, nothing much changes. However, for Glowworm, what we did is actually not just change the brightness or rank them by all the brightness of all off-screen objects, but just rank them within one color, which leads to this result. So yellow, blue, and green all have the same brightness level now. If I introduce a new blue one, which is further away, we rank, it actually gets assigned a lower brightness level. Once we now stack things, for Halo, also the concentric arcs get stacked. For Wedge, the algorithm tries to keep the triangles apart. For Firefly, we chose a Halo-like approach where things get stacked, while for Glowworm, the 3 notifications are just placed side by side. As ambient light has a smaller display space, or a smaller design space as a display solution, our goal was that to achieve at least a performance that was not significantly slower than Halo and Wedge. However, we thought that due to this nice separation between screen and off-screen, people would actually like it more as it prevents clutter. As a task here, we had a finding node task, so people were shown a node on the surface, and we measured the time that it took them to find the node on the screen and then clicking on it. So they had to move around on the screen with the mouse. We also used NASA TLX tests to measure the task load. In this experiment, we had 10 participants, 3 female, with 6 wearing glasses. And from the performance, we see actually that everything is significantly faster than the baseline. However, the difference between the different conditions is not really visible here. So we zoom a bit in and see that Wedge actually confirming the results from literature is the fastest one here. However, Firefly not being significantly slower. On the preference side of things, all the participants preferred the ambient light visualization. However, they were undecided which one they like best. And now it gets interesting. Once we look at the overall task load, we see that Firefly has a significant lower task load than all the other techniques. Glowworm does not so well here. And also for the frustration levels, Firefly does significantly better than all the other techniques. And this comes down mostly to the people who said that actually they had really an easy time with mapping larger objects closer to as closer objects and smaller notifications as further objects. So this was considered quite right for many of the participants. On the other hand, while Glowworm actually objectively provided more information due to this color ranking, especially people who are not so literate on computers had a hard time to utilize that. Some more technologically literate people did quite well with that, and actually for them it was the fastest technique. So to sum that up, we don't see a significant performance difference of our ambient Firefly with Wedge. Users prefer ambient light, and there's no clear winner between the techniques, and Firefly does really well in overall task load and on the frustration level. So what do I have to do when I think or when I want to design for ambient light? First, it's crucial to consider the user's position. So if the user stands close to the board, it's really tricky to see notifications. However, they can do really well for people in the background. Second, if you want people to really spot something animated, if you want to use brightness for some indication, it's crucial to do gamma correction, and even if you don't, then it's a good way to do that. Moreover, if you have the chance to use size over brightness, it's preferable. And if you need more color resolution, then it's good to add light separators. So we also looked a bit into possible applications and their utility. So we have the virtual 2D workspaces and the emergency response we saw in the beginning, but also some other application scenarios. So here we have a task where we have a posted landscape. People move around. We have the emergency response scenario, where an incident is indicated by a red flashing light, and our users can just jump right to that. A remote activity also works nicely, as we can indicate the position of a remote user without cluttering any screen space. And we can also use ambient light as some sort of a portal to link for proximic devices and have new content coming in from there. So to conclude my talk, we augmented a large interactive surface with ambient light. We analyzed the impact of different user position on this perception of notifications, compared ambient light to different off-screen visualizations, deducted a couple of design guidelines that should be considered when designing for large interactive surfaces with ambient light, and also highlight diverse application scenarios that could show some potential for this technique. With this, I conclude my talk and open the floor for questions.
Thank you very much. So again, okay, we'll take one that's close, but then just please gesture towards me.
Hi, I'm Thomas from University of Bremen. Have you considered combining on-screen and ambient light together, and also not using like a bar other than an arc also on the off-screen so that it forms a circle?
For the off-screen visualization?
Like in a combination of ambient light and on-screen, and also not using the bar as an on-screen other than an arc to form a complete circle.
For highlighting different distance on the off-screen visualization task, you mean?
Also to better perceive it as you're coming closer, because when you have only a bar on the top, it's really hard to see when you're closer, but when you have like on-screen and off-screen, it's better for both.
For both tests that we did, you mean?
Yeah.
Okay. Well, especially for the first one, on the notification side of things, we really tried a lot of different form factors. We did not try both at the same time, as we actually wanted to see which one works better. But we tried different form factors. We chose the bar because it's actually convenient to then later write text into it. And we actually had done an application where we used exactly off-screen objects indication like that, so have text titles there, and this was where the bars basically came from. It might be interesting to show it with, to combine it with some sort of Halo-like approach for off-screen visualization, but we haven't considered that.
Okay.
Heiko Müller from the University of Oldenburg. Thank you very much for your talk. I really like that. Can you just speculate a little bit on the limitation of ambient light, that it requires like kind of a dark environment, and then when you're using a very large wall display that is brightly lit, you will get into fatigue problems maybe quickly? Have you experienced that in your studies?
Actually, what's interesting is that the ambient light, in contrast to the projected display, is quite bright. So the darker the room gets, the more fatigue problems we have. So in the studies, we had actually quite a bright room. I mean, the application videos that I showed have a dark room because it looks nice in the video. But actually, people complained more about, they complained more about having a problem with ambient light once it's got darker. So yeah, in the paper you'll see that we actually tried to have a 300 lux environment and 600 in the front on the board. So it was quite well lit, and it was not so much a problem for ambient light, more that the actually the screen looks really dim in that case.
Thank you very much, Florian. Thank you.